Prior to spring break, we were working on some tools that would help us monitor variation in a production process, meaning are there things there that are unexplainable? Are there things there that are explainable? More specifically yet, we're looking for what we refer to as special cause variation. This is special cause variation is usually caused by problems in the calibration or the wear and tear of our capital that we're using in production. So we start out with control charts, and we'll have three different types of control charts, but the type of control chart we use depends on the type of data we have. And so if we have data that can be measured with a meter stick or with a micrometer or some sort of physical measurement, we'll use what we're going to start with is this C chart. And we went over this in class, but I thought it might be worthwhile to go over again. So what I'm looking for is a methodology for following this flow chart. Okay. So the first thing is that I need to calculate sample means. Now I probably should look a little bit deeper at what that even means, right? We're looking, we're in charge of a production process, and at some point in time we will draw a sample. Now the sample here is pretty small because nobody wants to type in 30 items per sample. So I'm looking at a sample where I'm just choosing 4 objects that we've produced, and I'm taking a measurement of them. And what this flow diagram says is, from that, calculate the sample means. Okay, so I might be doing sample means as I go, right? I can calculate, I can draw this first sample, and I can record the measurements, and then I can calculate an average. Okay, when I grab the second sample, I can enter the data, and I can calculate an average. And then, since I have 10 samples and no averages for 8 of them at this point, why don't I just copy this down? And now I have a mean for each sample, which is what my flow diagram said to do. Calculate sample means. Okay. Well, the next thing it says is, do I know the population mean? Now, the chances that I know the population mean are fairly slim, but I might be working with a product like ball bearings that have to be exactly 2 centimeters in diameter. That might be our sample mean. So, but our problem doesn't. So I just follow this path that says no, and it says, oh, we'll calculate the mean of the means. So that's my second step in this process. I've calculated the means, and I have them all here. What it's asking me to do now is calculate the mean of the means. So that's just another use of the average, and I'm just going to highlight the means of each sample. And I now have the mean of the means, which is a very good estimate of the population mean. All right, so the next step in my process says my center line is going to be this mean of the means. Oh, okay, I could fill that in. I know that my center line is going to be equal to the mean of the means. Or I could just simply keep track and know that my center line is the mean of the means. Okay. All right, well, let's watch into the next step of our process. Calculate a standard error. Well, I don't really know exactly how to do that until I follow this a little further. And it says, do you know the population standard deviation? Once again, something that is not very likely, but could happen. I mean, somebody might, from the amount of experience with the process, they might have an estimate of the population standard deviation, but our process, the answer is no. And so we come down here, and this says calculate the, first off, I should explain what this R sub j is. That is the range. It's a measure of variation. It's the largest value in a sample minus the smallest value in a sample. So to run this process, find the mean of the ranges, first thing I've got to do is find the ranges. So I go back to my table, then we go back one page, and I find the ranges. This is equal to the largest item in a sample minus the smallest item in the exact same sample. So the range from smallest to largest is 1.1 units. And I need to have a sample range for every sample. So I'm going to copy that. I'm going to copy that calculation in cell H3 all the way down to H12. And notice there's a little bit of movement in these ranges. Sometimes they're a little further apart, and sometimes they're pretty close together. Okay, further apart, I think I marked the furthest apart seems to be this 1.3, and closest together seems to be the 0.6. Okay. Well, the next step in the process says to calculate the mean of those ranges. So I am going to go back, now that I have the ranges, and I'm going to calculate the mean, or the average, that's what Excel calls it, of the ranges. And this is going to be part of my measure of variation. So it says that the average of the ranges is 1 unit. Okay. All right, well, what comes next? According to this, I can now get the upper control limit and the lower control limit. Okay, to get the upper limit and the lower limit, I need this object, this A2 object. Well, A2 comes from table 6.1 on page 230. And the information that I need for A2 is the size of each sample. Okay, not the number of samples. I need the size of each sample. So I'm going to go in and say, well, what's the size of each sample? And then obviously, I could just count. But I'm going to use the function count and just have it say that there are 4 elements in each sample. So now I go to table 6.1. You should be on page 230. I go down the column labeled sample size until I find the number 4. And when I find the number 4, then I can put in a value for A2. Okay. Value for A2 is 0.729. Okay. So I have all of the information that I need, kind of methodically, right? Mean of each sample, mean of the means, ranges, mean of the ranges, upper control limit, lower control limit. Okay? So let's go and let's get this upper and lower control limit. Okay. This upper control limit, notice all I have is my X double bar, the mean of the ranges, and this value of A2. Now, I don't know if you recognize this calculation, but it looks an awful lot like a confidence interval from your days in stats. So I have the mean, and this is essentially 3 standard deviations up from the mean, and this is essentially 3 standard deviations below the mean. Okay. All right, so my upper control limit is 13.829. And my lower control limit, which is calculated as X double bar minus A2 times R bar, which gives me 12.371. Okay. Well, this is the end of going through the process, and it's the end of this particular video. But in the next video, I want to take the information we've collected and I want to create a control chart using the information that we have collected. So I will talk to you in another video.